Hello everyone, welcome back to another lesson on topics on integration. But in this video, we will learn on the evaluation of definite integral. So in our previous videos, we talked about indefinite integral. But when we say indefinite integral, we have what we call arbitrary constant c in our equation. Since in indefinite integral, we are evaluating or we are producing a general form of equation, or hence other known we have general solution. So we do not have yet a definite answer or definite integration to that particular function, whereas in definite integral we have a definite answer. Okay, so our answer here is an exact or a number. We don't have a variable to this one. Since in definite integral, we have limits in the function, and that is we have, for example, that is when we have integration of our function of x dx, we have a certain limit that is, let's say, that is from a to b. Now, what is the application of a definite integral? Like, for example, if we want to determine the area of a region, like this one. So basically, we have a limit here that is from a to b. Okay? So definite integral, one of the application of definite integral is when we want to determine the area of a region bounded by curves, bounded by lines. Okay? So this is a preparatory topic now for the application of integral. Now, how are we going to compute for definite integral? We have here when we have function of x, and this function of x here be a given function, and this capital letter F, function of x, is the integral of fx. Like, for example, if we want to compute the integral of this one, then we have this function of x. This is our integration, and this one is the indefinite integral. And we have limit, we have a to b, and a here is the lower limit, and the b here, that is the upper limit. These are the two given values of x. So our definite integral here, that is the difference when our upper limit is being substitute to the function of x here, minus when our lower limit is substitute to the function of x. So this is the result of this is our is the definite integral. Okay, so it is pretty much simple lang, since what we need to do here is to substitute the lower limit and the upper limit in the function. Okay, so let's try to solve basic example lang in definite integral. Like, for example, we have the integration of x dx. We have the limit from -3 to 1. Now, the first thing we do here is first to compute for the indefinite integral of x dx. So we have, of course, since this is a power rule formula, okay, that is what? That is the integration of ur du, that is u raised to r plus 1 over r plus 1. In this case, our u is x, and our du is dx. Okay, and our r, we have our x raised to first degree, of course. Okay, now let's substitute this value to this form, and we have here that is equal to, that is the integration of x dx. Then we have x dx that is equal to our u, that is x squared, since we have r plus 1, that is 1 plus 1 over 1 plus 1, and then we have the answer x squared over 2. Now, we do not have to put a arbitrary constant c, since we have limit from -3 to 1. So we have limit from -3 to 1. Our lower limit is -3, and the upper limit is 1. Then we substitute first the upper limit, that is we have 1 squared, that is the value of x, or 1, over 2, minus we have -3, that is our lower limit, substitute lower limit to our function, that is we have -3 squared over 2, and that gives us the answer, negative 4. Okay, so this is now the definite integral of the integration of x dx when we have our limit from negative 3 to 1. Now, we can check our answer if it is correct. We can actually use calculator to this one. Then if you have your Casio calculator, all we need to do here is to press this button. We have the integration sign here. So you click that, then we encode this integration form. That is, we have x dx, we have alpha x dx, then we have the limit from negative 3 to 1, and that gives us the answer negative 4, with the same as with our final answer. Therefore, we have correct answer. Now we have second example here. We have the integration of sine cube x dx when our limit is from 0 to pi over 3. Now take note, we cannot apply power rule to this one since we don't have enough du to satisfy our u here. If we let our u here, that is sine x, then our du should be cosine x dx. But take note, we don't have cosine in the integrand, so we should not use power rule into this function. But we can actually use trigonometric identities to this one. No? Now, if you remember your trigonometry, we have different trigonometric identities. Like this one, we have the unit circle. If you remember this one. Now, we have sine squared theta plus cosine squared theta is equal to 1. We have tan squared theta plus 1, that is equal to secant squared theta. Or we could have 1 plus cotangent squared theta is equal to cosecant squared theta. And we also have sum and difference in angle, this one. So you have to memorize all of this. So it may help you in dealing trigonometric functions involving trigonometric identities. We also have double angle here. So remember this, all of these trigonometric identities. And we also have angle formula, this one. So I would suggest to familiarize all of these trigonometric identities. Okay, so some of the students find integrating trigonometric functions difficult because they are not familiar with all of this formula. Okay, let's go back to the problem. The integration of sine cube x dx, we have limit from 0 to pi over 3. Now in this case, we can actually break sine cube x into two trigonometric function. We can rewrite this as integration of sine squared x times the sine x dx. As what you can see, we divide sine cube x into two. The first one is we have sine squared x, and the second one we only have sine x. Since if you combined this one, you could have sine cube x dx. Now what's the reason? Now, what's the purpose why I divide it to 2? Now, take note, sine squared x here could be expanded into trigonometric identities. Now, we know that the trigonometric identities of sine squared x is equal to, that is 1 minus cosine squared x. Then we have sine x dx. So, this 1 minus cosine squared x, that is the trigonometric identities of sine squared x. Okay? Now, in this case, we can distribute sine x dx inside the quantity. All we need to do here is multiply sine x to 1. That is, we have sine x minus, we have cosine squared x sine x. Then multiply sine x to cosine squared x. Then you have dx. Then you have the limit from 0 to pi over 3. Then, since we have two terms here, we can integrate them individually. So we can say that it is the integration of sine x dx minus the integration of cosine squared x sine x dx. We have limit from 0 to pi over 3. Pi over 3. Now, since we can now use, in this case, we have integration of sine x dx, that is just basically the integration rule, that is the integration of sine u du, which is equal to negative cosine u plus c. Now, our u in this case is du, is x. So therefore, the derivative of x is dx. Correct? So upon checking the integrand, we have this one is our u, and this one now is our du. And we have observed that our du here have already satisfied the required du. So we do not need to introduce a multiplier in the integrand. We can now directly use this formula, that is negative cosine u plus c, that is negative cosine x. Then at the second term, we have cosine squared x sine x dx. Now in this case, we can apply power rule. We can rewrite this one as the integration of cosine x then squared sine x dx, wherein our u in this case is equal to cosine x. R is 2. Then our du is the derivative of cosine x. We have, of course, negative sine x dx. Now, upon looking at the integrand, we are lacking of negative sign. If this is our du, we are lacking of negative sign. So we multiply negative 1. Outside of the integration, we multiply 1 over negative 1. Okay, now take note, since we have already negative sign outside of the integrand, so if we multiply negative times negative, then we could come up with positive sign outside of the integrand or in between the two terms. So in this case, we can apply power rule, that is u raised to r plus 1 over r plus 1, or in our u is cosine x, that gives us cosine x raised to, we have r plus 1, that is 2 plus 1 over 2 plus 1. Okay? Now take note, we do not need to put c or arbitrary constant c here, since we have limit, and our limit is from 0 to pi over 3. So our function here, or the function of x, that is negative cosine x plus cosine cube x over 3, and the limit is from 0 to pi over 3. Now we substitute the limits to the function, and in this case we substitute first the upper limit, and we have upper limit of pi over 3, so we have negative cosine of pi over 3 plus, we can separate 1/3, then we have cosine of pi over 3. Now take note, our cosine x here raised to the third power. Okay? Then we have the minus, since from the definite integral, we have the function of a minus the function of b. Okay? So in that case, we use a negative sign in between the two functions. Now we minus. Now take note, you always put a bracket, since we have two terms here. Negative cosine, then it's now the time for 0 to be substituted in the function. So we have cosine 0 plus 1/3 times cosine 0. Now take note, it is raised to the third power, then we have the closed bracket. Now, why we need to put a bracket here? Okay, meron kasing times, no, these are some of the common problem of student. If we do not put bracket at that point, we would have misinterpretation that our negative sign here only directs to the first term, but know that the negative sign directs to the whole function or the whole terms. Okay, so later on, this sign will be distributed to terms inside the bracket. Please take note of that. Now, while using your calculator, make it sure that our angle is in radian. So how are we going to check? So if you have your calculator, make sure that in the upper screen of your calculator, it indicates there letter R, that that means your angular unit is in radian. But what if it is in degree? So what you need to do here is to you click shift button, then the mode, Then change the angular unit into radian by choosing number 4. Yan. So that's how you're going to change your degree. So again, since in this equation we are not using degree, we are using radian since our angle is in terms of pi over 3 radian. So how are we going to evaluate? So we have encode all of this function in your calculator. So we have negative cosine of pi over 3 plus 1/3 cosine of pi over 3 since it raised to third degree, then minus, then the bracket or the open parenthesis, that is negative cosine 0 plus 1/3 times its cosine 0 then raised to the third power. Then we have 5 over 24 as our answer. Okay, so this is the definite integral of sine cube x dx from the limit 0 to pi over 3. Okay, now let's try to check it using calculator. If you have this one, you click this button. So that is sine. We have raised to third power. Okay, sine x, then raised to the third power. Then our limit is from 0 to pi over 3. And we have 5 over 24 as our answer. So we have a correct answer. You can actually check your answer if it's correct or not by just using your Casio calculator. We have example number 3. We have the integration of sine cube y cosine cube y dy. Limit is from negative pi over 2 to pi over 5. Now take note again, we cannot directly use power rule to this one since we have two different integral or trigonometric functions here, sine and cosine. They are combined as one function, and we have exponents to both trigonometric functions. We have third exponent to both. So in this case, we have to apply or trigonometric identities into this one. So we have to use trigonometric identities so that we could convert this function into a function that is integratable. However, we do not have specific rule to this one. So you always choose which trigonometric identities that best fit for this function. Wala tayong step-by-step procedure, so it is more on strategic operation. So it is your strategy na lang on how are you going to evaluate this one as easiest as possible. So in this case, the same as with the previous problem, sine cube y, we can expand that into two terms. That is, we can have, that is sine squared y, then we have sine y, then we have cosine cube y dy. Okay? Now take note, sine squared y here could be changed into its trigonometric identities, that is 1 minus cosine squared y. Then we copy the other function, that is sine y cosine cube y dy. Then we have limit from negative pi over 2 to pi over 5. Now, in this case, we can distribute sine y cosine cube y inside our quantity or our parenthesis. So we multiply sine y cosine cube y to 1, this one. So we could have the value, let's rewrite this as cosine cube y sine y minus, we have multiplied this term to cosine squared y, then we have cosine 5y, you add the exponent, of course, no, that is basic rule in algebra, then that is sine y, then we have dy, and then we have limit from negative pi over 2 to pi over 5. Now in this case, since we have two terms, then we could integrate them individually. That is, we could have the integration of cosine cube y sine y dy, limit from negative pi over 2 to pi over 5, minus we have the integration of cosine 5y sine y dy. We have limit from negative pi over 2 to pi over 5. Okay, so in this case, we can integrate them using power rule. No, this one, we could use power rule to this. And our u here is equal to cosine y, correct? And our r is 3. So our derivative of u, that is negative sine y dy. Now, in the second term, we have our u here is still the same. We have cosine y, our r is 5. Then our du is negative sine y dy. So let's try to check our du. Our du is sine y dy here. So we are lacking of negative sign. So we multiply negative 1. Outside of the integral, we multiply 1 over negative 1. The same as with the second term, we are lacking of negative 1 here. Then outside of the function, we multiply 1 over negative 1. So we can now use power rule, and that is cosine 3 plus 1, we have 4y over 4. However, we have negative outside of the integrand, we have negative sign at the back. Then in the second term, since we have negative here, then we have negative 1, then we could have positive sign in between the two terms. In this case, apply power rule, we have cosine 5 plus 1, we have 6y over 6. So that is power rule. Then we have limit from negative pi over 2 to pi over 5. So we substitute first the upper limit and then the lower limit. So we have here the first one, that is cosine. Our y is pi over 5. And we know that this one is raised to the 4th degree. Then we have over 4 plus the second term, we have cosine, substitute upper limit pi over 5 raised to 6, of course, over 6. Then minus, then take note, you always put a bracket, that is negative cosine, that is the lower limit, that is negative pi over 2 over 4. Then take note, this one is raised to 4. Then we have plus cosine of negative pi over 2. Now take note, this one is raised to 6, and that give over 6. So this is now our function. So we have the answer here, that is equal to negative 0.0604. So therefore, we have the integration of cosine cube y sine cube y dy, when we have our limit from negative pi over 2 to pi over 5, is equal to negative 0.0604. So let's try to check it using our calculator. We have, now take note, let's check if our unit here is in radian. Okay, so we have the integration of cosine. So we do not have a variable y, so let's try to use x instead na lang. 3. Then we have sine x raised to 3. Then we have dx. Then we have limit from negative pi over 2, then 2 pi over 5. So we have answer here, negative 0.0636, or that is negative 0.0604. So we have the same answer with the answer from our calculator. So therefore, the integration of cosine cube y sine cube y dy from negative pi over 2 to pi over 5 is equal to negative 0.0604. So this is our definite answer. Okay, we have example number 4, that is the integration of x plus 1 times x minus 2 dx, our limit is from negative 2 to 0. So in this case, we cannot directly apply rules in integration, but we have to simplify the function first. So here we can use the square of binomial or the polynomial operations. That is, we have funny face, if you remember. So all you're going to do here is to multiply first term to first term, then first term to second term, and so on, if you remember your algebra. So in that case, we have x plus 1 times x minus 2. So you multiply first term to the first term here, that is x squared. Then we have x times negative 2, then we have negative 2x. Then we have x times 1, that is plus x. Then we have 1 times negative 2, that is minus 2. So I hope you remember your algebra. Okay? So in that case, we have x squared minus x minus 2. So this is the simplest form. So we can rewrite this function as integration of x squared minus x minus 2, then dx from the limit negative 2 to 0. So from here, we have three terms, so we can integrate them individually. So we have the integration of x squared dx limit from negative 2 to 0 minus the integration of x dx limit from negative 2 to 0 minus the integration of 2 dx limit from negative 2 to 0. So in this case, we apply power rule to this one, correct? That is, we have 1/3 x cubed. Then the same as with the second term, we could apply power rule, that is x squared then times 1/2. Then we have to this one, that is the first integration rule, that is r dx. So we can take out 2, then we have 2x. Now take note, we have limit from negative 2 to 0. So we substitute first 0, the upper limit, then we have 1/3 times 0 cubed minus 1/2 times 0 squared minus 2 times 0 minus, then don't forget the bracket. We substitute negative 2, that is negative 2 cubed over 3 minus negative 2 squared over 2 minus 2 times negative 2. We have answer, that is, now take note, since we have value of x here which is equal to 0, then we could say that all these terms equal to 0. Okay, so this is 0, this one is 0, this one is also 0, then we have 0 minus, that is negative 2/3. And this gives us, since we have negative outside of the bracket, then we have negative times negative, we could have positive value, then we have positive 2/3. That is the definite integral. So let's try to check it using our calculator. So then the answer should be 2/3. So we have correct answer. Then we have number 5, question number 5, that is the integration of x squared, x plus 2, then limit of negative 2 to 2. So in this case, we could multiply x squared inside the parenthesis, that would give us, that is integration of x cubed, of course, x squared times x, that is x cubed, plus 2x squared, then we have bracket of dx. Our limit is from negative 2 to 2. So by power rule, we could say that is x fourth over 4, correct, plus 2x cubed over 3. So I computed it directly na lang. So I'm sure that you are already familiar with power rule, but if not, please watch my video discussion on power rule. So we have limit from negative 2 to 2. So in this case, we substitute first the upper limit, that is 2 raised to the 4 over 4 plus 2 times 2 raised to the 3 over 3, then minus, substitute the lower limit, but don't forget the bracket, so that later on this negative sign here will be distributed inside the bracket. That is, we have negative 2 raised to the 4 over 4 plus 2 raised to negative 2 times negative 2 raised to 3 over 3. then we have answer equals to 32 over 3. So this is the definite integral. So if you try to check your calculator, let's try to check it using calculator. This gives us 32 over 3. So we have the same answer. And we have last example here. We have the integration of 5 raised to 3x dx, limit from 1 over 6. In this type of function wherein our base here is constant and our exponent here is variable, we could not use power rule to this. Again, in power rule, our exponent there is constant. But in this case, our exponent here is variable. That is the integration of a raised to u du, where our u here is any function of x, and our du, that is the differentiation, of course, of u, and that gives us a raised to u over the natural logarithm of a plus c. So this is the integration rule to this one. Now in this case, our a is equal to 5, our u is 3x, therefore our du here is 3 dx. Now take note, the same procedure with other integration rule, we have our du here should be 3 dx, but take note we only have dx, so we multiply 3, outside we have 1/3. So in this case, we have 1/3, that is the a raised to u, that is our a, 5 raised to 3x, over the natural logarithm of a, that is the natural logarithm of a, our a is 5. So our answer here is 5 raised to 3x over 3, the natural logarithm of 5. Okay? Now we have limit from 1 to 6. So we substitute first the upper limit, we have 5, then 3 times 6 over 3, the natural logarithm of 5, minus the lower limit, 5 times 3 times 1 over 3, the natural logarithm of 5, and that gives us definite integral equals to 7.9 times 10 raised to 11. The integration of 5 raised to 3x over from limit 1 to 6. So we have answer that is equal to 7.9 times 10 raised to 11, which is have the same answer with manual procedure. So therefore, 7.9 times 10 raised to 11, this is the definite integral for integration of 5 raised to 3x dx when we have limit from 1 to 6. That ends our discussion on definite integral. So I hope it makes clear to you. And then if you have questions, you can post in the comment section below. And for more videos, don't forget to like and of course subscribe. Thank you for listening.